Hello everyone and welcome back to Stat 385 for another video. So in this video I'm going to go over the 6th lab assignment. Okay, so NFL scoreigami. I'm going to just zoom out just a little bit. Okay, so to complete this lab you should first watch the video, which will present some necessary and fun background. So let's just check that out. We're not actually going to watch the video. Oh yeah, no ads. And then next, explore the visualization in a more static website form. Okay, so first of all, let's get a sense about what we're doing here. So what we have is a graphical display of scores from NFL games, football or American football games. And you can see that in each entry here that we can see like what the winning team put up and what the losing team put up. And we can switch to counts for the occurrences of each of these different scores. And so, and then there's more background and detail and interesting little tidbits about this graphic and constructing it that we could, that you can go into. Okay, cool. And so I want to say, I apologize about all of the sports examples in this class. Myself, I'm not necessarily the biggest sports fan in existence or anything close to it. It's just, I really do think sports data is, one, easily accessible, and two, what's the way to say this, presents problems for analysis that have tangible solutions that are actionable. And I guess what I mean by that in the context of, like, say, baseball, which I'm more interested in than this, that you could think of baseball as an experiment with very similar playing conditions for over a century. And where in a context where every single outcome is tracked, charted, measured, and you have an abundance of useful descriptive statistics that could be used as inputs in some further analysis. And that is very different than data that you get in a lot of other contexts. And so that in some sense, these sports examples are great for serving as, like, or I should say, not sports examples, not the ones that we're covering in this class, but sports data in general is good as a testing ground for modeling approaches that you may want to use in some more general applied setting beyond sports. But this is a great testing ground for such like statistical modeling development and stuff. So although it comes across as I'm a big sports fan, I'm not. I enjoy developing statistical procedures and I enjoy sports data for the reasons I just stated. Anyway, but nonetheless, I can see how some of you just like sports, some of you don't like sports. Those of you who don't like sports, at least I hope that there's an appreciation for using these examples for the reasons that I have given here. And I do side with you somewhat on, I'm not that interested in sports, but I do really like sports data. Okay, that being said. Okay, so don't forget that there is a lab video posted. It will be important for completing this exercise. I'm going to assume that you're just going to read this at some point and then follow the video to get to the answer that you need for this lab. Okay, so first of all, what we're going to do, okay, so we're going to create this grid. We'll actually create a variant of this grid. We're not going to create this grid perfectly, but we're going to try to get as close as possible. So, namely, the things that would be nice to see is axes that are generally of this form, where they're labeled, first of all, with descriptive labeling names. They have counts here that are hopefully readable. They have green values for things that have happened, unencumbering white space in places they didn't. In other words, there's not too many grid lines that are just otherwise chart junk and distracting. And then impossible values that are blacked out. So largely speaking, that in the NFL or in games in general, you can't win the game and score less points than your opponent, at least in these type of in a game where more points wins the game, then you can't score less than your opponent and win the game. Okay, so that's why these are just blacked out. And then due to rules in the NFL that I don't know, don't understand, and am not interested in, there's a few other impossible values that are blacked out. Okay, so the script here essentially exists to get started. And what was I going to say? And chart and track those impossible values. Okay, so now we have this here. Let's go to our studio. I'm in fa24. So let's just load everything in. Tidyverse. Okay, so we can see we got all of the packages ggplot2. We're going to use that quite a bit. And then we need to run this. Right, when you get the NFL data, it takes a little bit of time to scrape it. Impossible 4. Okay. So let's see here. We'll just get started with just kind of introduce the idea that we can, make plots, right? So I'm going to use this NFL data, and let's just create a histogram mapping equals, okay, you know what? I actually need to see the data before I can go to work here. All right, let's view the data. That's right. I don't know these variables that well. Okay, so let's see here. We have season. We're using all the years from, 99 to 2021. Game type, regular season, game day, okay. Score variables. Away score, home score. And we can see some stuff here. Man, they have a lot of gambling variables and fantasy stuff. That's strange. Quarterback, coach, referee. Okay. So of these variables, if we're trying to chart the outcome scores for the winning team and the losing team, then we're gonna have to do some creation of the variables from home score and away score. So you can see that in this case, away team won, and then the next case, away team lost. So we're gonna have to do some manipulation too. It's not like the away team always wins the game, right? So we'll have to figure out something for that. Okay. All right, so great, I have that. Okay, but before we get started, let's just make some plots. Recalling that we have a top layer in which we specify a data set and can specify a global mapping aesthetic for all of the subsequent layers. Okay, but typically we can work within one particular layer specifying the aesthetic. So we'll specify home score, and how about minus away score, and see what this does. Okay, we can see a histogram. So looks like most of the probability mass from this histogram is shifted to the right of 0. So at least marginally across these games, it looks like home field advantage is a real thing. I don't think that should come across as too much of a surprise that the stadium that you typically play in with your fans behind you helps you win games, at least on average. And of course, there's lots of variation in that because, we have teams that are better than other teams, so that makes sense. Again, also with sports examples, there's concepts that are easy to communicate because they generalize to all kinds of games, and it's very sensible across wide audiences. So sports example is fun, even if sports is not. Okay. Okay, we can also just ggplot. Let's do data equals NFL plus geom point. So these are like very typical plots that we can make. Mapping equals AES. And let's just plot away score. Y equals home score. That's interesting. Okay. So getting a little bit closer. Maybe we start with a histogram. Obviously this isn't this, but okay. So actually, let's go to the course website. And in particular, let's find that, where am I? Functions. Uh-oh. That's right. I haven't posted. I'm making the videos now. Okay, so let me go to the web page that is going to exist. Okay, week 9, and render this on my computer. Okay, great. And then let's go to, and you should have this, you won't have to go through these back-end steps to get it. The ggplot cheat sheet, let's have that up. Okay, so we did stuff like in a previous video, we went through some of this, and of course with the implication that in that video and in the reading that we're not covering this entire thing, and that this entire thing is not all of ggplot. So, but in the stuff that we covered in this video, or the previous video, this kind of plot is hard to imagine how we're going to do it. So maybe we could try, so if we're having these score variables, maybe we can restrict attention to this side of the table, 2 variables, both continuous, and we could just try some of these. So, okay, point, we just did. Smooth, we've done previously. This rug plot, I mean, just by the description, doesn't look like that's gonna work. Maybe this is kind of cool. Let's see here, and we can just try a few of these out. Okay, I'm just gonna replace that directly. Geom hex, what's it look like? Would I like to install it? I would like to install it very much. Okay. Well, that's cool. Now we can imagine making improvements or changing around the graphics slightly. I don't think this will be an improvement, but that's a really cool plot. Okay. Bin 2D. Let's see what that looks like. Looks pretty good too. Okay, and that's getting closer. It has a color gradation on the side to specify information about the counts. I don't think we necessarily want that gradient. Okay, so I know I said 2 variables, but there's a few down here which are also nice. And I'm just gonna skip ahead and go to geom tile. So we're not gonna get into, yeah, this is looking pretty good. Okay, so, right, so that looks pretty good. Okay, so let's see here. And I can see, okay, now, give me 1 second. Bins equals 30, hexabin, okay. Let's do slight viewer here. Okay, I'm gonna do NFL. Let's select home score, away score. Let's just get a sense of this data again. And I can just wrap viewer in this using the pipe operator. Okay, so I can see there's a lot of shutouts. Do I have any? I guess I'm a little bit worried about missing this. Okay, anyways. I'm going to, okay, then try to do some data manipulation. Filtering out NA values for home score, just in case they're there. And then check this out. Then we can do ggplot right away. So, okay, so I'm doing dplyr stuff here. And then at the end, I'm going to do a pipe operator and then call ggplot. So this thing right here, whatever I'm doing here, will be entered in as the tibble for the data argument in ggplot. Fun. So now things shift to switching from pipe to the plus operator, and we get this. Okay, it's the same plot. All right, so nice. Now I can do, in one big command, I can do further data manipulation and further graphical specification all in one line and not have to store things. So I think that we'll just mostly work with this. Recreate score. Is that how it's spelled? Scoreigami. Looks good. Okay. So I have home and away score. I want to do win score and lose score. Noting that I already have some impossible values with these variable names. Loss score and win score. This is done just to make everything on the same line. I sometimes do that, or sometimes I'll just write lose. But since it's already defaulted at loss, we're going to keep it like that. Okay, so we need to create these variables. Okay, so need to do further data wrangling. Let's do mutate. Win score equals. Okay, so I have two columns of scores, away and home. One of them wins the game. Or how about this? We'll focus on, we'll lump wins and ties together. Okay, is that how it was done up here too? Yeah, so here we can already see that the win score has a 1 and the lose score has a 1, and that was called a, Anyways, we're gonna just do win score, tie goes to the winner. Or rather, tie goes to the home team, we'll say. Home score. Okay, so if the condition is this, then we report home score. Oh my gosh. Yeah, that's okay, sorry. I'm in home score, and otherwise report away score. Okay. So if the home score is greater than or equal to the away score, report the home score, that's the winning team, and not, if it's not, then away score. Okay, that makes sense. All right, we need to do the same thing for LLS score. So if home score less than, greater than, okay, we can actually just switch it. And then we get home score, away score. Okay. You could do this, you could keep it this way and then switch these around, or you could just do that. Okay, I think that's easier. All right, so let's see now what this looks like. Oh wait, I didn't change what was plotted. I want to do x equals win score, y equals loss score. Okay. It's not in the right spot, but we're getting closer. Okay, so what do we need to do now? Okay, we got to figure out how to flip that plot. Let's go to genomes. Okay. Remember on this sheet, there's this coordinate function thing. Coordinate systems. Coordinate fixed. Okay, so I think this is a good one to try. Coordinate fixed. And let's see here. Actually, I'm going to check out that function. Chord fixed. Fixed aspect ratio. Expresses y over x. Okay, so I think that we want the ratio fixed so that the ties appear on the line, on the 45-degree line. So let's try it. Okay. So I need to actually do, okay, so that's cool. It's, okay, what did it look like before? So it's a little bit, okay, so that's turning everything into nice little squares. Okay, great. But I want to flip things around eventually. Okay, so that's gonna recenter it. What happens if I do this? Aha! Not suddenly that flipped everything around. Awesome. Okay. All right, so nice. So we'll flip everything around. Is that kind of looking like what we want? Yeah. Okay, so we have this whole triangle that needs to be black and this needs to be a different color. Okay, so let's see here. I can use inside geom tile. I can do some graphical specification, right? Or some specification to change colors. I think so. Okay, geom tile, aesthetics, color is one of them. Okay, I'm appreciative of them for allowing me to, oh wait, no, that goes into geom tile. Okay, you know what? I'm gonna just, I don't want to run out of room here. I'm gonna specify this thing globally, so it's not gonna change anything. Well, it does if I don't do things correctly. Mapping equals. Oh. Okay, yeah, that doesn't change anything. Okay, so color. I'm appreciative that they let me specify it without the U, because that's just not something that I'm used to, and we can try green. Okay, so that just colors the border. I think we want to do fill, to fill in the different points. Okay. That's okay. That's cool, but I would say that this is, although it is green, it's not what we want here or it's not what they did, and I don't think it's an improvement. So I can specify dark green. That's cool. I like that. But I think that if we want to use these numbers in here to see the counts of each one of the times that these scores happen, then this light green is going to be hard to pick a color that's going to be nice. So I'm going to pull a little magic. Out and do that. So you can find, I guess, atypical colors through searching, and that is what I did. And I have stored this one specifically for this. Okay, so now, okay, where are we at? Can we zoom in on this? Why is it not zooming? Ah, there it is. Okay, so it's getting there. We have plenty of stuff to do. We can see we got bad access names. We have this gray background. We have reference lines. So let's get rid of some of these reference lines. Okay, and to do that, we will need a scale function. Okay. Let's now use scale. Okay. X and Y locations. So this is going to use specific aesthetics on the different axes directly. And I know from playing around with it that this will allow us to change around what's depicted on the axes. I'm going to consider it over for games or for scores between 0 and 100, even though 100 is too much. I just don't want to pick out the maximum right now. Okay, cool. And let's do the same thing with Y, the Y-axis. Okay. Looks good. However, we have reference lines. You can think that they're useful in this case, but I don't think they are. Plus, in between here, we have these little crosses. It's kind of just annoying, so probably want to get rid of that. And okay, so also this plot is a little bit cumbersome, so I'm gonna zoom in just a little bit. 30 for the Y limit and X limit, 0 to 30. Okay. Nice. Now, getting rid of dash lines can be specified in the theme environment. So let's see here. We could try, I'll just try the top one and see what happens. Okay, and let me look at the help page. Baseline size. Is there documentation? Oh, base size. Fonts. Base size for line elements. Oh, okay. Let's see what that does. Baseline size equals 0. Aha. Gets rid of all the lines. Nice. Okay, and are these axes in the right? The axes are reversed. Let's go to our scale function, since that previously messed with the axis in a way that was very useful. Let's see what other things that we have in here. Breaks, let's see. Section.axis. You specify a secondary axis. Okay. Specify a secondary axis. Trans breaks, labels. Okay, so that's going to mirror it. And I think that's actually pretty good to have, instead of having one reference axis, having two is something that I think is actually fairly beneficial. So let's go with that. So I should say that I'm not just pulling all of this out of nowhere and going this fast through it. I've worked on this for quite some time, and now I'm doing a video on it. So it's not like I have all of this memorized and I'm just kind of jogging my memory for any type of plot to do. I spent time working on it and then am now going through it with you. Okay. So here we have, okay, nice looking plots with axes. Looks pretty good. So we have a few annoyances. I think that right now the path of least resistance, or the thing that's most annoying, is that this plot has just like really bad labels. Okay, so let's go to our handy dandy cheat sheet, labels and legends. And honestly, I think this is probably just good enough. Just copy it in. Okay. Wait, do I want to do black, white? That's pretty good. I think that there's some other ones. Oops, what did I do? Did that not change anything? Okay, well if it didn't, then we'll just do that. Okay. Whoops. Okay. Oh, Classic gets rid of that. Is that what we, it's kind of nice. What does Scorigami look like? It doesn't have it. Okay, let's get rid of that. Nice. Wait, what does minimal do? I always like minimal. I think that looks good. Okay. X-axis. Winning or tie score, or tying score. Y will be losing score. Is it called NFL Scorigami? I think it is. Yeah, we'll do title NFL Scorigami. Subtitle. Do I want one? Yeah, the range of the data, 1999 to 2021. So I should note here that this won't contain all of the data from all NFL games. It's from 1999 to 2021. If you watched the video on Scorigami, they have like data from way back in the past, and you could do that, but that would be merging together lots of data sets, scraping and obtaining that data, and then putting it all together into one data frame. That might be annoying and tedious. However, if you want to do it, you would definitely gain a lot about doing our programming, and specifically working within dplyr. Okay, caption. Let's credit the author. Inspired by John Boyce. Okay, and what does alt do? Kind of like that. Okay, I'm not sure what, that's fine. Okay. Okay, so we got nice axes. We've removed the box that this contained in. All right, so what do I need to do here? So we have a little bit of a problem with the graphing here. We don't have impossible values yet, so we'll need to do that. Okay, so how do we get rid of this problem? Okay, so essentially that's going to be changing the coordinates slightly. 0.5 and negative 0.5. 30.5. Okay. Yeah. Oh. Silly me. Okay. Things look a little bit more symmetric. Hopefully there's still some gaps in here. Doesn't do anything. Okay. Keep it for now. And come back to it. Okay, so... Oh wait, maybe there's... Actually, you know what? Chord fixed. Let's see if there's more things that we can do. Okay, limits for X and Y axes, ratio. We're happy with these two. Small expansion factor, the limits to ensure that the data and the axes don't... Oh, okay. Let's default is true. That seems to be the problem, is that the axes are too far away from the data, so perhaps that will fix it. Aha, learned something new. Okay, that looks much better. Okay, great, I was gonna say. Okay, awesome. Thank you, documentation. Okay, so now the main problem seems to be not having the impossible values specified. So here we have in black impossible score values, and then here we have values that just haven't, scores that just haven't occurred, which are possible. All right, so now we need to do adding in the impossible values. Okay, so what's gonna happen with this? What's the way to think about this? What we need to do is add a new geome for impossible values. And we need to plot them on here. Okay, so here we have, and this was key in the initial construction, was we created our NFL data set and we did some mutation up front, creating these win-lose score variables. And then notice that the impossible values have the same labels. So what this is going to do is it's going to, if I just do this, geome tile data equals impossible, because everything up here is already using this naming convention, we are going to get with our global, with our mapping specified globally within geome plot, we are going to be able to use everything above for these values. I'm pretty sure that's how it's going to work. Aha, great. And the default must be this like blackish gray thing. Perfect. Okay, nice. That works pretty good, doesn't it? Okay, okay, so now we are zoomed in. Let's get rid of the zooming, and the zooming in, and let's get, let's still decide on a coordinate system. We want I think what we want to do is get the maximum winning score and the maximum losing score in this data set. Okay, so this could be a summary command, right? A summarize, sorry, I said summary, I meant summarize. Okay, so let's go down. So I'm gonna need a little bit here. I'm gonna need this because I want although I could just do it directly with home and away, can't I? Oh, whatever, I've come too far. Okay. Since these are just these are just use them in different spots, use home and away in different spots. It doesn't add or subtract anything from home and away score. I could just use home and away directly. But as I say, I've come too far. Select win score, loss score. And then let's do this. Okay, so I get these variables, and then I'm going to summarize max win score. Does that do it? Okay, good. Max loss score. Okay, 62 and 51. So we need x-axis goes from negative, okay, 62.5 and 51.5. Okay. Is that right? Okay, so 3, 0. Okay. Okay, looks good. All right, so we got a few more issues. We want to add counts, and we want to minimize some of the overlap on the axes names. The axis labels for the x-axis in particular. Y-axis actually looks pretty good. Okay, so we need to do some further specification. All right, so let's see here. Let's first add the cell counts. Okay, where should this go? I don't think it actually matters. But let's do it here. Okay, so we're gonna add cell counts. Let's go to, how can we, they're gonna display as text, right? Okay, geomes, aesthetics, 2 variables, 3 variables, 1 variable, common aesthetics, stats, fascinating position, labels and legends, zooming. Okay, themes, position adjustment, scales. Bar, geom, 1 variable. I think it's just, I know that this is count jitter, map limits. Graphical parameters, rect ribbon, primitive. Coordinate system equals plot, stat, position. Okay, where is what I'm looking for? Coordinate facet. Aha, position adjustments, no. Okay, so I think we're beyond the cheat sheet a little bit here. Okay, so unless I just didn't see geom text, we're gonna wanna display this as text. And I know from experience that it's geom text. Okay, so we want to, Oh, that's right. Okay, so I need to do a little bit more. I actually need to get the count information first before I can display the text. Okay, so sorry. I need to do a little bit more here. So select. Oh, no. Okay, so sorry. Everything depends on win score, lose score. So I can just select those variables, first of all. Win score, loss score, okay. And then I can group by, since some of these values occur more than once, I can group by, I guess, essentially just unique combinations of win score, loss score, and then I can count them up. Creating a new variable using just the typical count thing. Okay. Okay, now I can display those counts. Mapping equals, okay, let's just go. This is getting geom text. Okay. the mapping is going to, okay, so so that's that mapping. And we are going to, let's see here. We are going to want to display those n values. And I think that the way to do this, actually, yeah, we're gonna have to go into AES because we're not displaying like scatter plot values. So we're not going to display something on an XY coordinate system. I'm pretty sure, okay, where's the documentation for this? Okay, AES, aesthetic, point color, point shape. I think it's a label. It doesn't actually have, so again, I've worked on this on the side. I'm sorry that the documentation isn't the best for this. And I should also spell mapping correctly. I'm going to use my aesthetic and I'm going to do label equals n. So this is the count that I created of all of the unique scores. And so let's see what it looks like. It's gross. Okay, so I'm going to change the color to white. Okay, it's better, still bad. Okay, so then I need to go back and what do I need to do? I need to mess with the theme and play around with the axes and sizes of things. Okay, so let's see here. Okay, so in theme, so I have theme classic, which I'm going to use. I can also do some additional adjustments. Okay, so let's do theme. Okay, themes are powerful ways to customize the non-data components of your plots. Titles, labels, fonts, backgrounds, grid lines, and legends. Okay, so that's definitely in the right spot. And I need to, okay, so we want, oh, awesome. We have text and we have axis text. That's gonna be useful, both of those, okay. I think both of those would be useful. Okay, axis text, for sure. We want it for all the axes, not just one. That's cool that you can customize different things for different axes. And then, okay, axis, lots of things. Wow. Can I just get out of this and do axis.text? Arguments. The title.text. Take labels on. Okay, so we're gonna have this thing as the main driving function. So what was that element? I think it was for text, right? Yeah. Okay. Element text. Size. It says deprecated. Just see what happens. Is he gonna complain? Okay. Well, did it complain? Oh, okay, it didn't. Okay, cool. Let's change that a little bit, make it a little bit bigger. Okay, so we can see now we don't have overlap in the numbers. Awesome. You know what, just to be a little bit more precise, oh wait, what was it? Let me go back. Because there's nothing wrong with the y-axis, so do we necessarily want to make those smaller? Okay, got it reversed here. Okay. Let's just make it consistent. Okay, great. What's the other thing we want to do? We could do, The plot caption, I guess, is a little bit large and annoying. So if you go through a detailed search in the documentation for theme, you'll find plot.caption. And I'm just gonna go right through it. I wanna change the text. Okay. I wanna make it something like this and give it a more background role. So I wanna change its color so it doesn't feature as prominently. And I also wanna mess with, actually, axis.title. I don't know how they look a little bit big compared to this. Okay, so I'm not necessarily going to get there, get the exact right size for this, but let's see what happens if I do size equals 7. Do we want it to be that small? Let's do 8. Okay. Not much difference. It's fine. Okay. All right, great. Is there anything else we could do? Oh, there's a lot of overlap in those numbers. Could that be fixed by E? If I play with this, does it change anything? No. Okay. Text equals elements. What does that do? Let's see here. So if I zoom in on this, did that change? Okay, so where was I? Label, geom text. Maybe I just want to do that directly. Okay, geom text. Geom text. Okay, so let's go to Node.js parse, data, stat. Where's aesthetics? Size. All right, so I can just do that directly. Size equals 3. Now, where is it? Ah, a little bit better. It's about the same. Size equals 1. Too small. 1.5. Okay. Yeah. Okay, I like it. Are there any other obvious things that need to be changed? No, I don't think so. All right, so perhaps this is now too great. I don't care anymore. John Boyes will be happy that his work is credited. Okay, I think that this looks pretty good. Okay, so let's just sort of wrap this. This has been a long video. Let's wrap this up real quick. Okay, so we started with, actually, let me go to the lab assignment. Okay, so you're not required to submit. Okay, so yeah, read this stuff. So we started with basically wanting to recreate this graphic. And we have scoring data from the NFL to get us started and some starter scripts to label the impossible values correctly. Then it's a double task of wrangling data using dplyr and then considering all the complicated layers that we want in ggplot. But we're able to do this all in one large command using both pipe operators and the pluses in ggplot. So then it's a matter of just, going in small incremental steps to gradually make the thing better, identifying what is, like, I guess, the thing that is going to be the most problematic fix or the most problematic feature of the graph at every single step. That's kind of the process that I employed with this. And then to figure this out is a combination of reading documentation, prior experience with ggplot, and making this plot in a script that, or making this plot before, so I kind of knew where to go. Right, this is kind of demonstrates the power of both dplyr and ggplot in one I guess, analysis or one visualization tool. And you can see how, this thing is, even the thing we've created, not exactly a very typical plot. And so it required us to use a lot of tricks. Okay, so that is it. I'm going to stop here. Thank you for watching. Read the assignment and watch this video, which you have, and you'll be good to go. All right, so thank you for watching. Take care. Bye.